Good morning, students. In today's class, I'll explain about the different operators available in C++ language. In our previous class, we studied about what are data types, what are all the different data types supported by C++, and what do you mean by modifier of a data type, especially with respect to basic data type. We studied the different modifiers available along with the range of value a particular data type supports. Data type is nothing but the type of value a variable can take. In C++, we have basically three categories of data types. The first one is basic data type that includes int, float, char. The second category is user defined type that include classes, enumerated type, etc. And the third category is derived type that include arrays, functions, and pointers. In today's class, we study about what are data types or what are operators, what are all the different categories of operators available in C++, what do you mean by expression, how to use operator in an expression. One thing you should know is all the operators available in C language are available in C++ also. But C++ has some additional operator. In today's class, I will explain only the common operators among both C and C++. At the end of this class, you should be in a position to understand what do you mean by an operator, what are all the different operators available in C++, how to use operators in programming or how to use operators in an expression, then what do you mean by an expression. Operators are nothing but symbols. Generally, operators are used for manipulation of data. The purpose of any computer is to process your data. In order to process your data, we need to apply some operator on the data. So that's the reason operator, we define it as a symbol used for data manipulation. By combining the operands and the operator, we'll get what is known as an expression. So operators are also used to combine the operator to form expression. Operands mean it could be either a variable or it could be a constant. The different operators available in C++ are broadly classified into three. The first one is unary operator, binary operator, and ternary operator. Unary operator is one which takes only one operand for manipulation. Binary operator needs two operands, and the ternary it is three. Every operator is associated with some precedence and some associativity. The meaning of precedence and the associativity I will discuss in the subsequent slide. Let us start with the first category of operator, arithmetic operator. C++ supports 5 different arithmetic operators which are denoted by the symbol plus, minus, star, slash, and percentage. The purpose of this operator you already studied in your C programming. It's just a recap. Plus operator used for addition, minus for subtraction, star for multiplication, slash division, and percentage operator we call it as modulo division. That is generally used to take the remainder when one integer operand is divided by another integer operand. All arithmetic operator, all the 5 arithmetic operators comes under the category of binary operator. That means in order to use any of these 5 operators, we require 2 operands. The percentage operator has a special property, that is it can be applied only for int type operand. Percentage operator cannot be applied for float operands, and it gives you the remainder of integer division. Let us consider a simple example. You take 2 variables, int a value equal to 8 and another variable b equal to 3. The result of plus operator gives a plus b gives 11, a minus b gives 5, a into b gives 24, a by b gives 2. Because the one special property of the slash operator is if both numerator and the denominators are integer type, then the fractional part is automatically truncated. In this example, both a and b are int type. Therefore, a by b, actually the correct answer is 2 point something, but point something is truncated, means the result will be 2. And a percentage b gives the remainder when 8 is divided by 3. When 8 is divided by 3, the remainder is 2. In case of percentage operator, the sign of the remainder always depends on the sign of the first operand only. It never depends on the sign of the second operand. Example, if A equal to 10 and B equal to -3. In this case, since the first operand A is positive, the result A percentage B is +1 only. In the second example, A equal to -10 and B equal to 3. Here the first operand is a minus or negative operand. In that case, result is -1. And the last case, both are negative. Both A and B are negative. Still, the sign of the result or sign of the remainder always depends on the sign of the first operand only. In the last case also, the result is -1 because the first operand A is negative. What do you mean by an arithmetic expression? An arithmetic expression is a combination of the operand connected by arithmetic operator. So if you use the operand and along with the combination of plus, minus, star, slash, percentage operator, the resulting expression we call it a arithmetic expression. Arithmetic expression always gives you some numeric result. Some number will be the output of an arithmetic expression. Arithmetic expression, depending on the operand you are giving, there are three types. One is integer expression. In an integer expression, all the operands are integer type. The next one is real expression, where all the operands are of float type. And the last case, some operands are integer and some operands could be float type. Operand means need not be only variable. It could be constant also. For example, you take the declaration int A, B, C. Here I have declared three variable A, B, C. All of them are int type. And the float D, E, F declares another three variables of float type. The first expression you take C equal to A plus B plus 20. Here A and B are integer variable and 20 is an integer constant. So the three operands are A, B, 20. Out of that one, A, B are integer variable and 20 is integer constant. The resulting expression is integer expression. The second case, F equal to C plus D minus 8.3. So here C and D are float variable and 8.3 is float constant. So since all the three operands are of float type, the resulting expression is called it as real expression. In the last case, A and B are integer, whereas D is a float type. That's an expression, we call it a mixed mode expression. Out of that one, integer expression, the result is always integer. Real expression, the result is float type. And in the case of mixed mode expression also, the result is float type. The second category of operator is relational operator. Relational operator is used to compare either two variable or used to compare two constant or to compare two expression also. The different relational operator available in C++ are greater than, less than, greater than or equal to, less than or equal to, and not equal. All the relational operators are binary operator. Because in order to use any of these six operators, we require two operands. Similar to arithmetic expression, we have a relational expression. A relational expression is a combination of operands. Operands may be either variables or constant, but connected by relational operator. The result of an arithmetic expression is some numeric result. While in case of relational expression, the final result is either true or false. Generally, both in C and C++, true is denoted by non-zero value and false is denoted by zero value. Example, you take two variables A and B with value 10 and 20 respectively. Then first case, A greater than B, since A greater than B is false, the result is 0. In the second example, A less than B, that is true, the result is 1. And the last case, A not equal to B, that is also true, the result is. The third category of operator is logical operator. Suppose you have two relational expression. One relational expression, the answer is true. For the second relational expression, the answer is false. Then what is the final result? One of them is true, the other one is false. In that case, the final result depends on what operator is there which connect these two relational expressions. So logical operators are used to form logical expression, are used to combine two or more relational expression. The three logical operators available in C++ are AND, denoted by two AND sign, logical AND, logical OR, and logical NOT. All these three operators are available in C also. Logical expression combine two or more relational expression. Similar to relational expression, logical expression also, the final result is either 0 or non-zero. 0 means false and non-zero means it's true. Let us take one simple example. If A equal to 10, B equal to 20 and C equal to 80. Here I have used three variable A, B, C with value 10, 20 and 8 respectively. So take the first expression, A less than B and B less than C. The first relation expression is A less than B and the second relation expression is B less than C. These two relational expressions are combined by means of logical AND operator. Here the first expression A less than B is true. And the second expression B less than C is false. So one is true, the other one is false. Since they are connected by AND operator, the final result is 0. So in case of AND operator, if both the relation expressions are false, the result is false. If one of them is false, the result is false. For the final logical expression to be true, both the relation expression must be true. But this the truth table of logical operator already are studied in your C language. In the second expression, A less than B is true and B greater than C, that is also true. So true and true, the result is true and that is denoted with 1. In the third expression, A less than B, that is true, B less than C, that is false, but now they are connected by OR operator. In the case of OR operator, if one of the relational expression is true, means the result is true. For the final expression to be false, both the relation expression must be false. So that is the difference between an AND operator and an OR operator. In case of AND operator, if one of the relation expression is false, means the result is false. In the case of OR operator, if one of them is true, means then the result is true. The next category of operator is assignment operator. Assignment operator is used to assign a constant value or the value of one variable or the value of one expression to a variable. So it is used to assign either the value of a variable. So in the case of assignment operator, we have two components. Before the assignment operator, you have variable, and to the right side of the assignment operator, we have either a variable or a constant or an expression. And assignment operator is used to form assignment statement. Example, if A equal to 9, B equal to 6 and C equal to 1.2, then X equal to A plus B into C, that expression we call it as, or the statement we call it as an assignment statement. Here what happens is, A is constant, A, B, C. The result of A plus B into C, first B into C, then its result is added to A, then the whole result is assigned to the variable on X. So the general syntax of assignment statement is variable equal to expression. In the place of expression, either you can have one more variable. For example, X equal to Y is assignment statement only. Or in the place of expression, you can have a constant. For example, X equal to 20, that is also valid. And in the case of, in the right hand side, you can have an expression itself. So an assignment operator also is a binary operator, because before in the left hand side of the assignment operator, you have a variable. In the right hand side, you have either a variable, constant or an expression. So we have two different components. Therefore, assignment operator is also considered a binary operator. The next one is bitwise operator. Why they are called as bitwise operator is, these operator manipulate data at binary level. That means in order to use this operator, the number must be in binary format. So some of the different bitwise operator available in C are single AND logic, that's called as an bitwise AND. If you write 2 times AND sign, that corresponds to logical AND. Only one single time if you write AND mean, that corresponds to bitwise AND. Bitwise OR, a cap sign or a caret sign indicates bitwise exclusive OR, and a exclamatory mark denotes bitwise NOT, and a tilde mark, that wave sign, denotes ones complement, and double greater than 2 times, it indicates shift. Oh, sorry, it says shift left, and 2 times less than sign, that indicate shift left. So it's a small mistake. You interchange that as shift right and shift left. Out of the different bitwise operator, and bitwise OR, bitwise exclusive OR, shift right and shift left are binary operator, whereas the tilde mark, that is for ones complement, and bitwise NOT, they are considered unary operator. I told you, in the case of bitwise operator, to use that operator, the number must be in binary format. Let us take one simple example. If a equal to 8, in your first semester you have studied conversion of number from one number system to another number system. So 8 in case of binary is denoted as 1000, b equal to 10. So 10 means 1010. Then a and b mean the extreme leftmost bit in both the number is 1. So since it's an AND operator, the result also 1. The second bit in both the case it is 0, there is 0. Third bit means from the left hand side. Third bit in both the number, in the first number it is 0, the second number it is 1 means since an AND operator the result is 0. And the last bit or the least significant bit in both the case it is 0 means it's 0. So bitwise AND of 8 and 10 is 1000, that is equal to 8 only. In case of OR operator, if any one of the bit is 1, the result is 1. So extreme leftmost bit, both the number it is 1, so it is 1. In second bit from the left side, both the case it is 0, 0. Third bit from the left side is, in the case of first number it is 0, in the case of second number it is 1, the result is 1. And the last bit again, both the number it is 0, it's equal to 1010. In the case of exclusive OR, if both the bits in the corresponding positions are 0, the result is 0. If both the bits in the corresponding position it is 1 also, it is 0. If they are opposite, in the first number it is 0, in the second number it is 1, or the reverse, and the first number it is 1, in the second number it is 0, then also it is 1. So in the case of 8 and 10, the extreme leftmost bit in both the number it is 1, the result is 0. And second bit, both the number it is 0, 0. And third bit, the first number it is 0, and the second number it is 1, that is equal to 1. And the last bit, for both the number it is 0, the result is 0. Whereas shift right and shift left, the meaning of the usefulness or the utility of shift right operator is, if you shift right any number by 1, that's equal to division by 2. If you shift any number left by 1 bit, that is equal to multiplication by 2. Here what I'm doing is, I'm shift right a by 1 bit. So the a value is 8. When you divide 8 by 2, the result is 4. 4 means 0, 1, 0, 0. And the second number b is 10. When you shift left that number, that's equal to multiplication by 2. So multiplication by 2 means 8 when shift left side by 1 bit, multiplication by 2 means 8 when multiplied by 2, it becomes 16. So 10000 is equal to 16. So this is the main application of shift right and shift left operator. Shift right is equal to integer multiplication by 2 or division by 2. Sorry, shift right is division by 2 and shift left is multiplication by 2. The next two operators are increment operator and decrement operator. As the name indicates, increment operator add 1 to the operand or 1 to the variable, and decrement operator subtracts 1 from the variable. The original value of a variable x equal to 10 means, then if you apply the plus plus operator, that gives you 11. If you use minus minus operator, that gives you 9. And both these two operators are unary operator, because you apply that operator for only one variable at a time. These two operators can be used either in prefix mode or in the postfix mode. That means you can either use it as a plus plus, or you can use it as plus plus a. They are one and the same. That means when the plus plus operator or a minus minus operator, when used with independent variable, they are one and the same. But used in expression, they mean different. For example, if x equal to 10, then y equal to plus plus x. So here the x is used as a plus plus operator is used as a prefix operator. So what it will do is first increment the value of x by 1. So x initial value is 10 means now it becomes 11, and 11 is assigned to y. So in this case, both x and y will be 11. The second case, I have used y equal to x plus plus. Here plus plus operator is used as a postfix operator. In case of postfix operator, how it will work is, first original value is transferred to the variable on the LHS of assignment operator. Original value of x is 10, so 10 is assigned to y. So y becomes 10. After that, x is incremented to 11. So in both the cases, x value is incremented by 1, but the y value in the first case it is 11, and in the second case it is 10. That means a prefix increment operator first increments the variable, then incremented value is assigned to the variable on the left hand side. A postfix operator first assign the original value to the variable on the LHS of the assignment operator, then the variable gets implemented. Comma operator. This is a special operator that is generally used to link set of expression together. In the case of comma operator, we have several expressions. Then the expression is evaluated one after the other. Only after executing the first expression, it executes the second expression. Only after executing the second one, it goes to third one. So it is generally used to link related expression together. It is this operator has the lowest priority or the lowest priority. Generally, this operator is applied at the last. Out of all the operators available in C++, this operator generally has the lowest priority. So a comma operator is also a binary operator because binary means need not be only two or more. Example, x equals to a equal to 10, comma b equal to 5, comma a plus b. So here we have three expressions, a equal to 10, b equal to 5, then a plus b. The first expression is a equal to 10, that is executed. That means 10 is assigned to the variable a, then 5 is assigned to the variable b. Then the third expression you can evaluate only after executing the previous two. So a value is 10 and b value is 5 means it becomes 15. So now x value will be 15. So in the case of comma related expression, without executing the first expression, it will not execute the second one. Without executing the first two, it will not go to the third one. So the expressions are executed one after the other in a sequence. The next one is conditional operator. A conditional operator is a special operator with respect to C, but the same operator is available in C++ also. It's called as a ternary operator because that operator generally takes three expressions. This operator is denoted by the symbol question mark followed by colon. The general format of a conditional operator is expression 1, question mark, expression 2, colon, expression 3. How it is evaluated is, first expression 1 is evaluated. You should remember that expression 1 is either a relational expression or a logical expression. We know the type of value a relational expression or a logical expression gives. A relational expression or a logical expression gives the value true or false. If the expression 1 value is true means, then expression 2 is evaluated. Otherwise, expression 2 is not evaluated. That means if the expression 1 value is false means, without evaluating expression 2, it evaluates expression 3. Let us take one simple example. A equal to 10, B equal to 8, C equal to 5 are the three different variables. Then x equal to A greater than B, question mark, plus plus C, colon, it's not double colon, it's a typographic mistake, colon, minus minus C. So here what happens is A greater than B is evaluated. Is it true or false? True. If it is true means, then the second expression plus plus C is evaluated. So C plus plus means it becomes 6. Now in that case minus minus C is not evaluated. The result is transferred. So 6 is transferred to x means x becomes 6. In case if A greater than, suppose A value is 10 and B value is 18. In that case A greater than B is false. In that case plus plus C is not evaluated. Minus minus C is evaluated. So minus minus C means C will be 4. Then 4 is assigned to x. So if expression 1 is true, then only evaluate expression 2. Then don't evaluate expression 3. If expression 1 is false, then don't evaluate expression 2. Then directly evaluate expression 3. The next operator is size of operator. Size of operator is used to know the size of a variable in terms of number of bytes or size of a data type or a size of a constant. Example, size of float. The size of operator in this case takes the argument as a data type. So we know that a float data type takes 4 bytes. Size of char is equal to 1. Size of 20. Here the argument is a constant. So it's an integer constant that also gives you 20. So where actually size of operator is useful is, size of operator is used to find the size of a structure variable. You know that a structure variable contains several members. Each member could be of different data type. First member could be a string type, second member could be array type, third member could be a float type, fourth member could be a double type, etc. So any structure variable is in the case of structure variable, the size of the structure variable is equal to size of the member name member 1 plus size of member 2 plus size of member 3 plus size of all the members put together. It's generally used to find the size of a structure variable or a union variable or an array or an object. Anyway, object I'm going to discuss in the next class or in the subsequent classes. The next concept is precedence of operator. What do you mean by a precedence? every operator has some priority. So which operator is generally applied first? Which operator is applied next? That is decided by, what do you mean? What do you call a precedence of operator? Generally, operator with highest priority is applied first, then followed by the operator with lowest priority. As an example, I have considered only three categories of operator: arithmetic operator, relational operator, and logical operator. In the case of arithmetic operator, the different operators are plus, minus, star, slash, percentage. Out of that one, star, slash, percentage are considered as high priority operator. So generally they are applied first. Then plus and minus are considered as low priority operators. In the case of relational operator, the different relational operators are greater than, less than, greater than or equal to, less than or equal to, not equal to. Here, greater than, less than, greater than or equal to, less than or equal to. These four are in the same level. They are treated as high priority operator. Equal to, not equal to, they are treated as low priority operator. They are applied in the second level. In case of logical operator, we have three level. OR operator, sorry, not operator is the highest priority, and is the medium level, and OR operator is the lowest level. So generally, precedence decide which operator has to be applied first. So without knowing the priority, you cannot evaluate an arithmetic expression. Sometimes what happens is you have operator with the same priority in an expression. For example, A plus B plus C minus C minus D. So plus and minus are in the same level. Then which is applied first? So in that case, whether the operator is applied either from left to right or from right to left, that is called an associativity or of an operator. The operators of the same precedence are evaluated either from left to right or from right to left. If it is evaluated from left to right, in that case, we say that the associativity of the operator is left to right associativity. If it is evaluated from right to left, then we say that one the operators associativity is right to left. Example, most of the operator have the associativity left to right only. Some of the operator which left to right priorities are plus, minus, greater than, less than, greater than or equal to, star, etc. Some operators, some special operator have the associativity right to left. They are plus plus, minus minus, conditional operator, assignment operator. Example. To understand what do you mean by an associativity, I have taken one simple example. If x equal to 6, printf percentage d plus plus x comma plus plus x. So in that case, we have to see what is the associativity of the plus plus operator. We know that plus plus operator has the associativity right to left. So in that case, rightmost plus plus x is evaluated first. So there the x value becomes 7, then followed by the next one. There in the first plus plus x will evaluate after executing the second one. So it becomes 8 and 7. So with this one, we have completed almost all the operator which are common for both C and C++. In today's class, we discussed about arithmetic operator, relational operator, logical, size of, bitwise, increment and decrement operator. We also studied what do you mean by precedence of operator, what do you mean by an associativity of an operator, the example for each category, and what do you mean by an expression. All these things we have covered in today's session. Based on today's class, these are some of the probable questions that may appear in your examination. Explain the different operators in C. Distinguish between unary, binary, and ternary operator with an example for each. Explain with an example categories like arithmetic, relational, logical operator, increment, decrement, bitwise, conditional operator, etc. So these are some of the interesting multiple choice question on today's session. Operator with the lowest priority. I told in the beginning only that in the out of the available operator, comma operator has the lowest priority. The correct answer is B. The next question is, what is the value of x in the expression? X equal to a plus plus star plus plus b. So here I used the plus plus operator with both a and b. With a I have used as a postfix. With b I have used as a prefix. You know what do you mean by postfix and prefix? In the case of prefix, first the variable gets incremented. In the case of postfix, first the original value of the variable is used for expression. So original value of a is 10 means 10 into first b is incremented, it becomes 6. 10 into 6, it becomes 60. The correct answer is C. What is the value of the following arithmetic expression? 10%3 star 5 slash 2. So there plus and star are same priority. So 10%3 means 1 into 5. 1 into 5 is 5. 5 by 2. In the case of 5 slash 2, both 5 and 2 are integer, means fractional part is truncated. The result is 2. The correct answer is A. The fourth question, which of the following is not a binary operator? Cap sign, binary operator. Shift right, binary operator. Plus plus, it's a unit operator. And percentage, again a binary operator. The correct answer is C. Operator used to link related expression is comma operator. The correct answer is D. Hope you have enjoyed today's sessions. In the today's session, I have covered only the common operator. I have not taken into consideration any of the operator which is available only in C++. In the next class, we discuss about the special operators in C++. Thank you.